Welcome back to Application Security Weekly. We just talked with Jack Cable about CIS's Secure by Design principles, the state of its pledge, and what we can hope for in a future with better software quality and lots of cats. I'm your host, Mike Shima. I'm here with Jackie McGuire. And wow, we've got a lot of news to get into, Jackie. But first, one of the things I want to do is, we didn't have time for this when we were in a chat with Jack, but he was riffing a little bit back to 2003, 2004, when MySQL and Microsoft SQL introduced prepared statements. I can trace, because I like to do these nerdy things, back one of the earliest references to SQL injection in general was a December 25th, 1998 FRAC article from none other than Rainforest Puppy, talking about web technology vulnerabilities. And he was focusing on Windows NT at the time, and it has some very classic, very simple SQL injection vulnerabilities in there. So 1998 to roll forward to 2025, we already have a few hundred, as I mentioned, CVEs for SQL injection. Who knows when that'll go away? I don't.
It's crazy to think almost 30 years of the same vulnerability. Yeah. Mm-hmm. And there's not many of us, I don't think, who haven't done something untoward with a SQL database accidentally. I've DDoSed my own website with SQL. So.
The best pwns are the self-pwns. But speaking of other things that are going away, but SQL injection is still around. But speaking of Microsoft and things going away, Skype is shutting down, and there's some fun things for that here. Back, way back the early days in this double-digit episode numbers of ASW, we were using Skype to record this. But I don't want to spend all my time in a nostalgic past, because the past wasn't always great. We have to remember that. Today, or what Skype did is, that I wanted to highlight, was set up a lot of E2E and put end-to-end encryption in our minds. And it brought it to a communication mechanism that just people used. And I think that's a great legacy to leave behind. And I don't know how much you've used Skype as well, Jackie, but that E2E stuff, I'm sure is something that you're appreciative of.
Yeah, I always preferred Yahoo Messenger, but
deep cuts.
But I think once Skype came around, I think your point is absolutely correct, in that this was right around the same time that broadband internet was kind of rolling out residentially, and it was more accessible, and I think more homes than ever were connected, and developing a lightweight E2E encryption protocol that broadband enabled, because it could handle larger data volumes, kind of revolutionized everything about how we think about texting and chatting with people. I don't know if people know that from like 99, 2000, you could actually video chat on Yahoo, but kind of combining it all into a little bit more of a familiar package. I think that's what Skype really did, is like it kind of bridged the gap between phone and internet that a lot of non-technical people needed. So
yeah, and it's great to highlight that idea that it had that user experience, as well as on the back end, let's say normal people or just regular people maybe didn't appreciate they didn't have to understand what end-to-end encryption meant. Yep. But they were being protected. And to this day now, once again, this is what the past can teach us, or we should learn from. Apple, famously has put E2E within their messaging. Android has as well. And now we're just starting to see them, the blue bubbles and the green bubbles try to talk to each other and in good encrypted ways. But we also see just this year, the UK saying, hey, Apple, you don't end-to-end encrypt all of that user data you're putting in the cloud. We want access to it. So even from the origins of Skype, there was government pushback. There was pushback from law enforcement. That hasn't changed to this day either. So good lessons there. Good things to be aware of.
Yeah. I just published a story a couple weeks ago. Now we've gone on to the next level of vulnerability, which is there's a couple spyware companies, one out of Israel and another one, I can't remember where they're based, that now supposedly can get into WhatsApp, Signal, Telegram. WhatsApp actually served them with a cease and desist a couple weeks ago for targeting Italian humanitarian activists on the Mediterranean. So yeah, it's really interesting. And I think, the backdoor, we were talking about this before we started recording. One of the things I'm optimistic about with a, legislative backdoor mandate is that Wall Street will probably never let that happen. Because if you think about it, if the largest companies in the world, the Apples, the Googles, all of that, have to put these backdoors in, one, they either have to put them in globally for everybody, and that's just how it works, which hopefully from a privacy advocate standpoint we wouldn't allow, or you're now talking about two separate development chains, right? You have your backdoor development chain and then your regular development chain, and I think the cost that would add for engineering for some of these companies hopefully would be a non-starter. I'm actually kind of surprised, I guess, that this happened in the UK first. You would think that this would be a US thing first, right? Like, I hate to say that, but the US's record on privacy compared to the EU and UK is so lackluster that I'm actually really surprised this happened there first. I don't know how you feel.
Well, I wanted to pull out too. I've made the joke on one of the past episodes of the show is that physicists famously try to model anything and become experts on any topic, and AppSec can also fall into that trap in the sense of, imagine a spherical CVE in a vacuum. And my point there is that vulnerabilities are not just purely technical in a piece of software. They're used for spyware, just as you were talking about that, how they're abused throughout the WhatsApp, Telegrams, iMessage as well, for that matter. And even just talking about end-to-end encryption has some wonderful, really cool cryptographics, that's the more fun version of crypto, math to it to figure out how do we know it's reliable, how do we have confidence in it, how do we know it's not being intercepted. But you can't ignore the policy, the law, the legal side of that, the social impacts of that, which you're very helpfully highlighting. And I want to use that, Jackie, to segue into another really fun article as we kind of continue on that subject. There's a really cool research called Wallbleed. This was a memory disclosure vulnerability in the Great Firewall of China, and about some researchers who have across several different universities, many out of University of Massachusetts Amherst, Colorado Boulder, if I get my words out today. But it has two fun aspects to it. One, it is a DNS parsing and injection type of vulnerability. So really cool things that just speak to me geekily. Here you have any protocol that has length offsets. How do you muck about with those length offsets? And then the overflow happens to be very Heartbleed-like, thus the Wallbleed name, is that it leaks memory. And what these researchers were showing, there's a lot of really interesting memory from DNS queries, as well as other application queries, application layer queries as well. And they were using this to see, how's the Great Firewall of China doing its censoring? How's it operating? What is it responding to? So it has that wonderful mix of the technical, but the social and policy. And let me turn it back over to you, because hopefully you found this as exciting as I did.
Yeah, I did. And, one of the things that I started thinking about was cultural differences and how vulnerabilities are discovered and shared based on cultural differences. Because when DeepSeek came out, one of the things that I pointed out was, well, China completely censors their culture. So the training data for DeepSeek, if it actually came from Chinese culture, comes from a much higher structured data set than the crap that's on the Western internet. And I think it's also interesting to think of it this way, if you really tightly control what people can do with the internet, how they can use it, if you continually monitor it, you're probably also negating their ability to fuck around and find out, right? So these vulnerabilities likely would have been discovered in China sooner if there wasn't such tight restriction on how you can use, whether you can try to break things, whether you can try to hack into things. So that was the first piece. My first degree program was psych, so I always go back to psych and sociology and what is the really broad climate that enables these things to happen. But yeah, I think it's really interesting to think with 2 billion people and all those resources, even the PRC still can't fix some of these issues. And the intersection between culture and technology that causes that.
Yeah, it's interesting to say that, because for me, this was this was a little bit of a callback to a conversation we had on the show a couple weeks ago with James Kettle, who was just talking about the top 10 web hacking techniques of 2024. And it was interesting to, again, slight yawn, but not so yawn, to see cross-site scripting SQL injection on that list. But it was because people were looking at binary protocols, or they're looking at different ways it was manifesting. And this Wallbleed research was actually kind of similar to that. And it's interesting too, because, the comment about, PRC, how is this not found, is that I'm quite sure PRC has the hackers and skills to find this, but it still falls into that. There's a cliche out there, with enough eyes, all bugs are shallow. I don't think we have those eyes have to be paying attention. They have to be looking. It's a little too glib just to be able to pass that along. But I wanted to highlight that too, because apparently this was also able to be leveraged over a period of roughly 2 years or so. So it's a vulnerability that they were able to exploit and use over a long period of time, which stands out to me.
Yeah, and I think DNS is really interesting. So one of my best friends, Joe Hall, works over at Infoblox, and they do a lot of stuff with DNS. And the last couple months, they've been doing some amazing things, but like 3 different people have told me that DNS isn't sexy. And so DNS is actually at the root of a lot of massive campaigns. It's at the root of being able to predict campaigns before they actually kick off, finding, subdomains that have been taken over that you don't know about. But because it's this there's an abstraction layer on top of it, so it's not something that even a lot of developers are super familiar with. I think a lot of the really big exploits in DNS get lost or kind of under the radar because it's not sexy. So
yeah,
I'm here to tell you that DNS is very sexy.
DNS is sexy. That might have to be in one of that goes on the list for our Application Security Weekly mottos. I like it. But
it might go on my tombstone. No, but it really is. It's an area of security research that I think more people should be focused on, because it not being sexy means it's also overlooked from the adversary side. So it's one of those places that, because there are only a handful of very smart people doing this research, you have the potential to make very large contributions and uncover some pretty cool things, when there's not a lot of eyes on it. So this is my little promotion for getting into DNS research, because I think it's often overlooked.
I love that. And part of the thing to amplify that too is a little bit of what we were talking about with James Kettle was found some vulnerabilities in cookie parsing, and he was doing some other exploit techniques with request smuggling with email. And a lot of it goes back to reading these RFCs, but reading the weird edge cases, or reading the weird the optional implementations or designs that nobody pays attention to but are actually supported. And that's what you really highlight in DNS. This isn't just you only resolve this host name to this IP address. It's these weird other sub-protocols and weird bits of the dusty areas of those RFCs. That's great to discover things. So that's a wonderful message. I want to take that message then and tie it to another article I had that is called "Do Not Write That Jailbreak Paper," which is almost saying the opposite thing. Don't research. But honestly, there's a couple of reasons I pulled this out. One, for me, I've said this before, like prompt injections, jailbreaks, they're starting to feel like the cross-site scripting of LLM security. And the spirit of this paper is also saying, like, it's okay to have jailbreaks. It knows about security. This paper even references the classic smashing the stack paper from Frack. Speaking of Frack articles, but it's looking for impactful contributions that give us new ways to exploit these vulns. Think of it as new vulnerability classes rather than just showing the trivia or techniques of here's yet another small variation to do a jailbreak or to do a cross-site scripting for that matter.
Yeah. Yeah. And, I think we were talking about this earlier when we were talking about stories. And I think I agree with this wholeheartedly, because it's great to watch somebody do a fun jailbreak and coax information out of an LLM that they're not supposed to have access to, or, convince it that it's, my fun thing recently is seeing people convince the free models that they're actually premium models and get the premium features out of them. But, sometimes on these things we're going for like the big flashy things. So like, tell me how to make sarin gas, tell me how to make an IED, like the crazy things. But that I think a lot of times prevents us from looking at the automated small security things that these LLMs are capable of that can very quickly get out of control. Or I had the lovely experience myself of training an LLM model and running up a almost six-figure AWS bill because one little piece of my code didn't limit the number of entries I was pulling from Elastic. And so, I think that the point here is that if we can't tie the fun stuff that you're pulling out of an LLM to an actual practical exploit or something that can cause damage, we're probably wasting a lot of time, resources, and compute for fun. And not that CTFs and those types of things are not great to build skills, but if you've got a whole team at your company who's doing this instead of actually looking at things like feature extraction and the actual thing exploits in models that will cause tangible enterprise damage or introduce tangible enterprise risk, those are a lot more important than, I convinced my chatbot to give me information from the dark web I'm not supposed to have.
Yeah, that's a great point. And even this blog post talks about that, in relation to the Smashing the Stack paper, it was pointing out that Smashing the Stack, it's fun. There's learning aspects to just playing with the stack overflow, buffer overflow, getting into heap overflows then afterwards. But what the important contributions came from new ways of exploits, like understanding return to libc, or figuring out how do stack canaries help, ASLR, control flow integrity. In other words, big things that have helped get rid of a vulnerability class. And as a bit of a callback to our conversation with Jack just in the previous segment, part of that secure by design is, what does that mean? Don't just do better or just do things like that are meaningful in the sense of rolling out MFA for cloud service providers. And this, one more thing I want to point out from this paper, because I did really like it, it does say, it poses the question, what does a meaningful jailbreak look like? And I want to highlight this because we could almost expand this to just what would meaningful security research look like, because it answers it suggests uncover a vuln in a defense or in a model that had previously claimed to be robust. Or, it's not just something that's iterating necessarily on an existing vuln. It's giving a new vuln class, or it's getting applying a new threat model to existing, threat models or technologies. And that's what we've seen with Orange Psi, looking back at the Microsoft Exchange and Outlook bugs, things that seemed old and dusty, but and the same thing with the DNS, as you're just pointing out, things that are out there that are decades old, but suddenly have some new and really fun things to discover in them from a security perspective.
Yeah. Or even from an endpoint perspective, I don't know what I did a couple days ago, but I have a almost brand new MacBook Pro that is on steroids for streaming and everything. And I was messing around with both ChatGPT and Gemini. And despite killing something happened that I ended up having some memory process went out of control. And no matter how many times I killed Windows Server and I could not get, and I had to do a hard it was crazy. So those are the things. It's when people talk about automating the SOC, I'm always get all your timestamps in the same time zone.
UTC, come on.
From your firewalls, exactly. And then we can talk about automating your SOC. And this is one of those things that it's the exploits with these things that are probably really valuable is endpoint memory overflow. Things like that, where you could start taxing a GPU on an endpoint because some of these things are running locally. All these little things that we're trying to go for these big, impressive jailbreaks when there's such small things that could wreak so much more havoc on the enterprise.
And it boils down to a lot of that aspect of, you mentioned earlier, kind of that idea of where do I focus my team? Where do I direct a team? Where do I focus my budget? Because we're trying to defend an organization, defend an enterprise. And absolutely, don't want to leave, and I don't think you're saying this either, our audience thinking don't learn XSS, don't play with prompt injection, don't play with jailbreaks. They are fun, and there's a creative thinking to them. But if you have a limited time and budget, do you do something like roll out passkeys, or do you spend another week or two playing with prompt injection?
Yeah.
Hopefully we know what the answer is to that one.
Yeah, exactly. And realistically, for most enterprises, a day-long prompt engineering class is probably going to be much more effective in your enterprise than focusing on prompt injection for a day, because keeping people from putting stupid stuff into LLMs is probably going to be more beneficial to your organization than worrying about them jailbreaking them and getting stuff out of them.
Indeed. And now I'm going to try and do, let's see if I can make this segue work. We've been talking about, Jack, the Secure by Design, getting business incentives or getting businesses to take ownership of the security outcomes for their users. I have another article here. This is from Wired about 1 million third-party Android devices have a secret backdoor for scammers. Now, one of the things, if you get into the details, this backdoor comes from actual pre-installed backdoor on the device, or it's because users have downloaded some malicious software from a third-party marketplace that then triggers or installs a backdoor, or it's just a classic click on this link from phishing that someone downloads, installs. But the point more is you've got 1 million Android devices out there. The article talks about what the backdoors could do, how it's related to, this is Badbox 2.0, and from the first iteration of it, and it's based on some research out of human security. But what I appreciated about this is that there's action in here and responses from Google about how to centralize a defense against this, how to try and make this better for those 1 million, those owners of those 1 million devices, rather than saying, hey, we're just going to blame the user for not being patched, or we're going to blame the user for clicking on that link. This is Google actually saying, here's ways we can help with the Play Store or help with detecting that this is present. So that's my trying to find some positiveness amongst today's doom and gloom from this article.
Yeah, I think this is... So I've been a green bubbler since it was the Motorola Droid. So I have had almost every version of every Google, Android, Samsung, you name it. I have only owned an iPhone when work required me to. So I'm super conflicted about Android devices because I love them. I love that I get to tell my phone what to do, that it's not out of the box, almost inflexible. But this has been a problem for years and years and years. Like it mentions in the article, car infotainment systems. And this goes back to, we lose sight of how relatively new software is as an industry. And because it's innovating so rapidly, there's always hesitation to put regulation around things. But when you talk, and we covered a guy who hacked his mom's Subaru a couple weeks ago on Enterprise Security Weekly. And this came up with, how long are manufacturers required to patch and support their infotainment systems? Because if I've got a car that's 10 years old, most of the time that's been deprecated, it's not supported anymore. So what's to keep somebody from finding a vulnerability and putting an info stealer in there? And, I think there's regulation is not something anybody loves, but a lot of these things I think could be addressed with regulation. I really want to know though, so one of the things it points out is that many of these devices are coming from South America. So like Brazil and places like that. And I think there's a supply chain aspect to this that's also really interesting, in examining where in the supply chain these compromises are occurring. If there's a broader campaign, if there's a reason that Brazil is the place where these are popping up most often, because those are always the things I think is like, well, why would there be so many unsecured devices in one place? That doesn't make a lot of sense, right? So, but yeah, I think, it goes back to there are two laws that we haven't really figured out in software, which is the right to repair and the obligation to support. And the combination of those things, as we continue to move down the line and innovate in technology, until we figure them out, I think this is where the majority of vulnerabilities are going to come from.
Yeah, and thank you for bringing up right to repair, because I was going to say the exact same thing and highlight how that is very much that collision of technical things, researching security, and clearly politics. Because if we want to fix my John Deere mower, not that I personally have one, but how I should be able to do that, and or go to that infotainment center on your car. At what point how long should we require the, Subaru or the provider to do this versus a third party could do that? But then how much trust do we have in that third party to not be backdoored, to have the security? Because as you're highlighting how the geographic shift of where these, backdoor devices are coming from, I'm going to be optimistic here and say that's just a sign of these low-cost devices are being developed in this geographic area, and other geographic areas where devices are being created possibly had, they possibly had better security around their supply chain. Mm-hmm. I don't know how much I can support that. Is definitely one of those talking head types of comments, but it's one of those things that's come to mind that would be curious to dive into.
Yeah.
Now, I want to switch us from just talking about all the vulnerabilities out there because Jackie will there's too many. We'll
I feel
die.
vulnerable enough.
So vulnerable. Yes, exactly. Let's talk a little bit about the building side of things. And here I have what is actually a very simple, very small article from the Rust blog. It's just their February project goals update. Now, not a very exciting title. It's also, I won't say a throwaway blog post because it's interesting to the Rust community. It's important. But I wanted to highlight it because it's talking about one of their goals for 2025 is stabilizing tooling needed by Rust for Linux. And this highlights the idea that I got excited, John got excited when we covered the Linux kernel, finally adopting some Rust for kernel for kernel drivers, which is a great attack surface where it's helpful to have more memory safety. But just saying that the Linux kernel adopted that glosses over that it took several dozen people several months just to get it to the point where you could do the equivalent of a hello world with the Rust tool chain and the tool chain that the Linux kernel needs to build itself. And clearly now in 2025, that's still going on. So when we were joking with last episode with Daniel Stenberg about why didn't, curl rewrite, all that C code into Rust over a weekend, part of it is that, as he pointed out, it just wasn't mature enough at the time. It didn't have everything that this curl project needs to run on 190 plus different operating systems.
Yeah. This is probably tangential, but one of the things that kills me about the fact that machine learning and AI have been completely overtaken by LLMs is that there are extremely important, useful applications for AI and machine learning like this, like developing more secure cross-platform languages, like making languages backwards compatible. Because one of the things that often prevents onboarding and making these things available on additional operating systems or bringing additional capabilities in is that when you have a technology that's been deployed for 10, 15, 20 years, you never want to break it. And so we've all had issues with backwards compatibility. I'm sure we've all broken servers that way. And it's a somewhat binary thing. And so this is a very easy application for something like, I don't even want to say AI because it's machine learning. It's decision tree. It's not even complex. And it kills me to think about how many billions and billions and billions of dollars are being poured into some of these extremely just like vapid, novel AI BS technologies when this is actually a significantly more important thing to be using it for. Because I don't know that most people understand that there are like probably a dozen technologies that really underpin everything in the world, Linux, things like, and so I think it leads to a lack of investment in those foundational technologies. And when we develop new technology, we tend to point it at fun, novel things, not making sure we're maintaining the foundation of what keeps the internet running. And so, yeah, so I know we don't want to talk about AI in an abstract conversation, but it's just one of the things that I'm like, why is this not what we're using all of that compute for? Why are we using, gigawatts of electricity and billions of gallons of water so I can have a AI best friend that talks to me like the Green Power Ranger?
You set me up for my perfect soapbox, so get comfy. I'll try to make this short. Of just if we talk about the CPU, pennies per CPU or dollar per CPU trade-off between having an LLM basically grep through my code versus having a fuzzer do the exact same thing. My hypothesis has long been the fuzzer feels like it's going to be much more bang for your buck, and it's going to be more effective. It's going to exercise a lot of those code paths. And if there isn't a use for LLMs, maybe the LLMs can just help the fuzzer build up its initial corpus or its initial test files that it uses to then go and perturb all the different inputs and outputs that it can figure out. But that is the lowly opinion of a Security Weekly podcast host. So we'll see how many people.
Well, I will validate that as a data scientist, because go ahead and, like, let's say you take something out of your tech stack, try to get your LLM to forget that thing was there, because you can't. You have to retrain your LLM. Whereas just taking something out of a fuzzer is a 10-second process. And that's what people don't really understand, is that LLMs are not flexible. They may be impressive because they introduce 1,000 layers of reasoning that makes them seem somewhat human-like, but they're extremely expensive to try to adapt, and you absolutely cannot make an LLM forget something existed. So Google forgetting Harry Potter, fantastic study in trying to get an LLM to forget Harry Potter ever existed. It starts forgetting wizards, castles, so you have to retrain. And it's the 6 months down the road when something changes, you're going to realize you should not have used an expensive LLM for something. And I agree, because the environmental impact of LLMs is something that cannot be understated, and the use of them for things that significantly more simple regression models, pattern matching, it's killing our environment. And I know people don't want to hear that, but it's a serious issue, and it's stupid. Like, using compute that doesn't need to be used is stupid.
Once again, you're giving me all kinds of candidates for good mottos for this show now. I appreciate it. But to your point, I want to use what you were just saying there about ML unlearning as a bit of a callback to that Jailbreak paper, because I did link into another paper that it also referred to about the title Adversarial ML Problems Are Getting Harder to Solve and to Evaluate. And just real quick, it was talking about machine unlearning is known for ML because you can actually figure out, does this particular do this particular phrase, or is this part of a set that the ML model is aware of? But when you get into LLMs, how do you remove knowledge about an entire concept? And that's not really, you have to go and just retrain. Otherwise, you start removing all the things about everything that's related to castles or trolls or et cetera, et cetera. So I think those are great points that you're bringing up about the challenges and the focuses on where to spend our money on fancy autocorrects.
Yeah. Well, yeah, and then if you talk about agentic AI, and then you're talking about having to go retrain 10 agents who all know something they shouldn't know, again, we're just creating extra layers of stuff when we haven't fixed the underlying quality of the data in the model issue that's driving most of the hallucinations and things like that.
Indeed. And I don't think I've been hallucinating this whole time, because even though we've been talking about tons and tons of vulnerabilities, they're just going to keep on coming. But I definitely haven't been hallucinating how much fun I've been having with you go through the news, Jackie. So I want to say thank you once again.
Yeah, thank you for having me. This was super fun. It's always nice to do something a little bit different.
This was very fun, very different, very important. I want to thank everyone for joining us as well. Please do remember to subscribe, share us on the socials, give Jackie a shout out. Check out our show notes. And speaking of the two of us dealing with all of these vulns, check out Two Graves by Street Cleaner. We'll see you next time on Application Security Weekly.